Good evening, all. I'm Tab Binding. I'm the project manager for the Riverside University Design Challenge. You'll get used to seeing my face as we go through this webinar series. And this is week 1, webinar 3, Counting Carbon. So on Monday, we had the climate challenge. Tuesday, we had sustainable timber and offsite manufacture. Tonight, which is, I've got my days mixed up, is Thursday. We are counting carbon. And tomorrow we have open house, which is our virtual pub. And it's for anybody who wants to come and let their hair down and become a community of climate challenge pioneers. We have a fabulous array of speakers tonight. So we have Adam Vaughan, Jo Jack Williams, Jane Anderson, and Tim Martel. And I am so looking forward to hearing about all the brilliant things they're going to share with us. So can I hand over to Adam Vaughan, who's the co-chair of the Sustainability Forum for RIBA Northeast and also director of JDDK Architects. Adam.
Thanks, Tab. That's a great intro. Yeah. So my name's Adam Vaughan, as Tab's just introduced me. I'm a director at JDDK Architects in Newcastle. We're for those of you who don't know us, we're a medium-sized practice. And we're all super keenly interested in low-carbon design. And I'm also co-chair of the RIBA Northeast Sustainability Forum. The forum's really about bringing together professionals in the region, helping to sort of develop skills and share experiences. So just a bit of Northeast context for you. For those of you who are based in the Northeast, you'll already know that it's an amazing place to live and work. As an architect practicing in the region, I've been amazed how the whole construction and development industry has started to gear up to meet the climate challenge just over the last year or two. It's been amazing to see. For example, at JDDK, we're involved with several low carbon housing schemes just a few miles from the competition site that we're looking at as part of this competition. And if I'll just share one anecdote with you. I was talking earlier this week to a supplier of a well-known supplier of heat batteries, part of the sort of low carbon heating systems, and he was saying for him, the Northeast really is leading the way in the rollout of the technologies that he supplies. So admittedly, we've a long way to go, but what's really exciting is that we've got clients talking about the climate crisis, and I'm convinced that things are going to start to happen really, really fast. So tonight, the Design Challenge competition requires entrants to meet or exceed the RIBA 2030 Climate Challenge, which you'll know, I'm sure is the, well, hopefully by now, it's the RIBA's flagship tool for meeting the climate crisis head on. So importantly, the Climate Challenge focuses on a really important set of metrics around operational energy, embodied carbon and water use, and we'll hear about some more of this in a bit. But what I would like to say is that we can no longer talk about sustainability in qualitative terms anymore. We need to get to grips with the numbers. And for students and young professionals in the audience tonight, this sort of climate literacy is going to be really vital for your future careers. For those of you who came along to Tuesday's webinar, you'll know that the focus was very much about introducing the 2030 challenge and also looking at operational carbon. Operational energy. Tonight's webinar, we're going to focus mostly on embodied carbon. Embodied carbon, I have to say, is really the elephant in the room for many architects. We all understand that this is something that needs our attention, but we're only starting to get to grips with it. And we're really lucky tonight to have some fantastic experts from the industry who are not only going to present the challenge, but importantly, they're going to share with us some of the tools that we need to solve it. So Tonight we've got Joe Jack Williams from Feilden Clegg Bradley Studios. He's also a LETI volunteer. We've got Jane Anderson, Director at Construction LCA, and Tim Martel. Tim, if you haven't heard him talk before, he's a Passivhaus Designer, a Retrofit Coordinator, and he's also a developer of the PHribbon. I'm going to let all the speakers introduce themselves in more detail as they start their presentations. If you have questions, please put them in the chat and we'll pick these up as we go along, and we'll have a Q&A session at the end. So without further ado, Joe, if I can hand over to you for the first presentation.
Brilliant. Yeah, thanks, Adam. Good to see so many people turning up on a cold, blustery night. And I do just want to echo Adam's point. There's a huge amount of excitement around sustainability and really getting it stuck into numbers. So this is just any opportunity to do these kind of talks, I think, is just absolutely fantastic. So I work at FCB Studios. I look after their kind of sustainability and their research. And really part of this is just liaising with interesting groups and making sure that FCB sort of stay at the cutting edge. But also the other side of this is about sharing the knowledge that we generate. We were one of the founding signatories of Architects Declare, and really part of that, one of the key things for me is sharing that knowledge. If FCB make 10 great buildings, well, what do you do? We make 200,000-300,000 a year. We all need to be doing this. So it needs to become part of that kind of, the way we all work. So I'm just going to share my screen. And that should all be coming through. Is that working? You should all be able to see I've got this kind of nice glow coming from this. This is my presentation.
That looks good to me here, Joe.
Smashing, fantastic. So I'm going to give a bit of a sort of reason why we're doing this, and then also just a bit of a talk about just putting in perspective operational and embodied. You already saw some amazing speakers talk about operational energy, so you don't need me to go over it. But just as a reminder, this is the kind of struggle we're facing. If we carry on as we are, we're going to be looking at kind of 3 degrees, this kind of meandering into 3 degrees of warming. There's people saying the right things, we're not really doing anything. And we really need to get down to this 1.5 degree consistent pathway, which is a huge amount of greenhouse gas reduction we need to do. And this is the graph from LETI. I'm sure James Woodall would have shown you this when he spoke the other day. This is 7 to 8% year-on-year reductions, and that's not even accounting for just how difficult it will be to reduce those last 7 or 8%. That first 7 a bit easier. That last 7 is going to be incredibly tricky. And just to give you an idea of that, this is the impact of COVID-19 on the global emissions of CO2 and the change in the year before. At the height of lockdown in April last year, we managed to reduce our carbon emissions by 17 to 18%, which took an awful lot. A lot of things changed, an awful lot of upheaval. Now, I don't show you this to say, gosh, it's insurmountable, let's just call it quits. Actually, it is really achievable, but we need to think about it and we need to make direct actions towards it. It is entirely doable. There'll be a bit of technology. We'll have to address a lot of our kind of common concepts and things that we're used to doing, but everything needs to start with a kind of numerical evidence, which is why it's so great to talk about these things today. So net zero carbon is something that's touted around. I'm not going to delve too much into this. This is the UK Green Building Council net zero framework. Really very good. Probably the only kind of framework that's currently out there in the UK. There are kind of other bits kicking around, but this is really quite a robust one. Has 2 sections to it: construction and operational energy, which we're going to talk about. So we're going to talk mostly about construction today, but I'm just going to quickly remind you about operational energy. So this is the UK electricity grid, and this was when I was making my presentation earlier today at 4:20. This is there's a person called IMK who's a great software developer, makes loads of intuitive kind of bits, but it just gives you a clue about how much energy we're using at any given point, but also where its source is. So is it, if it's the green stuff, so is it wind, is it solar, is it hydroelectric, or is it coming from the kind of bad stuff, your kind of oil and coal? So you could see today it's cold, it's not particularly windy, so we don't have an awful lot of it, but we still got a lot of power requirement. So an awful lot of it was sort of fossil based. because it's not always like that. We're getting to around a third of the year, tends to be around sort of that kind of area. So it tends to be renewable over a third of the year. It's quite amazing, and we are getting a lot better from it. And if you look at it sort of hour on hour of the day, you can kind of see those peaks and troughs when it gets windy and it gets sunny, when people use lots of energy. And you can kind of see there's a really interesting point. So Adam mentioned thermal batteries when we were chatting earlier. You can kind of see actually there's a reason for batteries might be useful. If I start to get energy when it's low carbon and then release it during the day, all of a sudden maybe you can half your carbon footprint. And similarly, I can also schedule stuff to work at night. So rather than running my dishwasher during the day when it's high carbon intensity, I can run it in the middle of the night. It'd really annoy my neighbors, but it's probably for the right thing. But I'd half my carbon footprint for my dishwasher or whatever else. What an amazing idea. Really super simple, just a timer plug. And this is what's happening. So I mentioned the grid's decarbonizing, and this is kind of where we're coming from, this embodied carbon. The electricity that we used to kind of vilify and say it was the worst of the worst. It was all coal, it was all gas, it was terrible. It was up at 0.5 kilogram of CO2 per kilowatt hour. So every kilowatt hour, that's another half a kilo of CO2 gone. But we're getting down towards zero in this period. Actually, this year, electricity emissions will be lower than for gas. So gas, there's not very much you can do with it. It does fluctuate a bit. I've kind of simplified the line. But actually, you burn gas, it releases a certain amount of CO2. So there's not a great deal you can do with it. But this is what's driving our push towards electricity. If you install an electric system now, in the future, it will become nearly zero carbon. It never quite gets to zero. There's lots of complex sort of grid effects that will sort of caveat those. So you can see already we're going to be looking at things like changing heating technology, moving away from gas boilers, ideally aiming for heat pumps. There's a big caveat here as well. We could use electric radiators. If you can get your heat load down far enough, actually electric's not so bad. But heat pumps really are the kind of future. Every kilowatt of energy you put in, we can get 2 or 3 out for heat and kind of usefulness from thermodynamic magic. We can't just avoid the fact that we can't just build rubbish buildings that need loads of heating. We still have a fixed capacity for how much energy is in that grid. If we don't pay attention to that, we won't have enough renewable power, and therefore we'll never have green grids. So we still need to have low energy buildings. And this is what that 35 from LETI, that's where that figure comes from. That's what we have as an acceptable allowance for new buildings. So we still need to use things like use a heat pump, all these kind of little steps. And I'm sure James went through these. Have a look through the Climate Emergency Design Guide, have a little review of it. It's got some great stuff in there. And if once you've got all that done, you can throw a PV panel at it and you can throw your renewable tech. This is a little table I use. This is for Leeds. It's as close as I can get to Sunderland. It's not too far off. It's probably fine. Actually, Sunderland is probably slightly sunnier than Leeds because it's on the other side. But this tells you, what way is your solar panel facing? So 180 would be directly south. And this tells you the tilt. So 0 degrees would be completely flat and 90 degrees would be perfectly vertical. And you can see exactly how much your PV panel, including all the losses and conversion bits and pieces, how much that will generate for you. So per meter squared. So a really useful little table. You can kind of see how much you can generate from there. So that's enough about operational energy. You've already heard lots about that. We're here to talk about embodied carbon. So this is the kind of changing situation. So we're going from a place where this little blue bit is the operational energy and the grey bit is embodied, where we used to be all about, the grey bit's operational, the blue bit's embodied. The grey bit was overwhelming, so this operational energy was the key aspect. And as we get towards the end, actually, we're seeing now that because the grid's becoming so green, it's all about embodied carbon. This is where we can make the biggest savings. Jane is going to talk far more about this, and it's probably a slightly more accurate version of this table. I think I call this Next Life because it seems to be a bit more friendly. But we're going to talk an awful lot about these bits. So I'll skip on because it'll become a bit clearer later. But what we're really saying is these kind of bits where we build a building, it used to be, again, 2/3 would be operational energy. When we start to look at ultra low energy buildings that we have to be designing, actually it's nearer a quarter for a house. But 50% of the carbon emissions from that building over 60 years will be even before it's left the factory. The contractor hasn't touched it. It's still sat in a warehouse waiting to be bought, waiting to be used. 50% is gone already. And then you can see these kind of bits, transport to site wastage, and then there's kind of maintenance bit, like ongoing replacement and refurbishment kind of aspects, and then a bit at the end, about 2% of, just depending on what happens at the end of life. So really important to capture these bits. And where do we need to kind of focus these aspects? A lot of it is related to the structure. That tends to be where it is. It depends on the scale of building. So when we look at big offices, it's nearly all structure. But as soon as you start getting down to smaller houses, your structure becomes your facade, and actually you can find that your facade is working incredibly hard. But also as a consequence of that, you can have an awful lot of embodied carbon in it, particularly per floor area. It's kind of a useful kind of start. Again, this is from the LETI Embodied Carbon Primer. Again, well worth a read. Got some great figures in there. I'm sure Jane will talk a bit more about some of these bits. Before I hand back to Adam, I just thought I'd give you a kind of a quick idea of some really simple embodied carbon actions from the LETI LETI Embodied Carbon Primer. I would say that ACAN have got a new guide coming out very soon on embodied carbon, which looks amazing, and it'd be well worth a read. I think it's coming out soon. I'm sure Seb can pop something in the chat, or Sam can. Firstly, build less. Do you need new building? The big thing. Build light. Building light. Reduce the weight. Easy wins. You also save costs. Build wise. Look at the site constraints. What do you need to do? Build low carbon. So where you have to use a material, can you use a better material? Build for the future as well. The kind of dismountable, flexibility. We put a lot of resources in there. Can we make sure those resources are useful in future? And also build collaboratively. We quite often just sit in our little silos, which is why this competition is so exciting. We're all going to be working collaboratively with it, and that's where we get the best responses. It shouldn't be architects designing the building and the engineers just making it work. We need to work together to find the most optimal solution. So we're going to do Q&A at the end, I think, but I'll hand back to Adam, and he can introduce his next speaker.
Thanks for that, Joe Jack. And I'm right in saying we're going to hear from you again shortly?
Oh, excellent. Yes. Yeah, you can't stop me.
Excellent. Brilliant. Well, yes, so let's hand over to Jane Anderson. Jane, if you're there, do you want to introduce yourself and share your presentation? That looks good to me.
Can you brilliant. You can hear me?
And we can hear you fine.
Lovely. Hi, my name's Jane Anderson. I'm a consultant working in life cycle assessment, which I'll probably explain, but it's basically the kind of broader study of environmental impacts, and I focus on the construction industry, so construction products and buildings, and I've been doing it for over 20 years. But I did originally study architecture at Newcastle, so it's nice to have a little association with the Northeast. So I'm just going to try and explain. Jack's has given us a really good kind of introduction to embodied carbon. I'm going to get a little bit deeper. Some of this, I don't think there's any harm if I say something again. I'm sorry, but yeah, we'll get it drummed into you eventually, so it makes sense. So why embodied carbon? So this is kind of another way of showing you the terror. We have what's known as a carbon budget. So if we want to stay below 1.5 degrees, there's basically a limited amount of carbon, CO2, that we can release into the atmosphere. And on that basis, this was actually in 2019, we had 8 years left. So we've kind of got 6 years left. So this is why we need to really radically reduce the amount of carbon so quickly. The slower we are, the more we're going to have to do to kind of mitigate and, if you like, dig ourselves out of the hole by trying to reduce the amount of CO2 in the atmosphere by kind of even more drastic means, rather than just being able to reduce our emissions. So, you know, when I actually first started looking at these kind of things, I did my master's and sort of started down this route in 1997. You know, if we'd started trying to reduce our carbon emissions then, we could have had a nice, slow, gentle curve. Unfortunately, we're kind of now here where this sort of curve is really, really steep. And everything that we do has got to be, you know, we've got to do the maximum. So it's kind of unfortunate, but we really do have to act like our house is on fire, as they say. The other reason why embodied carbon is really important, we call it the lock-in effect. If you think about when you're designing a building, if you're looking at operational carbon, whatever system you put in, it's possible to go in, you can put more insulation into your loft, you can put a more efficient boiler in, you could swap from your gas boiler to an air source heat pump in the future, and the grid is going to decarbonize. So, I mean, it's better if you put, if you really act now to put as much insulation into your building and really focus on reducing embodied operational carbon. But it is possible that you're going to be able to make changes. Once you've made those building materials and that you've put them into your building, there's really nothing you can do. You've locked that environmental impact, that emission, that's locked in. You know, if you want to take something down and put a more efficient wall in, you can't reduce the impact of the wall that you've already built. So this is why it's really, again, important that we do something now and try and focus on these emissions. So what is embodied carbon? Jack showed you this diagram, but basically in construction we divide everything up into different life cycle stages. So we start right at the beginning with raw materials extraction, and so that's things like growing forests and cutting down forests for timber. It's extracting clay and minerals to make bricks and cement and concrete. And extracting mineral ores to make steel and other metals that we're going to use. So we follow all of these through the transport to take them to factories, and then the manufacturing process. And then we transport them to the site, and we look at the processes that actually occur on the building site. And we call this upfront carbon. So it's basically carbon that happens before you actually get into your building. And embodied carbon is upfront carbon, and then it's all the carbon that's associated with building materials through the life of the building. So any repair, replacements, maintenance, and refurbishment. And then these other green bits at the end of life of your building. What happens when you actually come to the end of life of your building? You demolish it or you deconstruct it. What do you do with the construction materials, the waste processing, any disposal? So these are all the impacts that we're looking at for embodied carbon. And then the bit that we're not looking at in embodied carbon is here, the operational carbon. But when we do a life cycle assessment, or what we call a whole life carbon assessment, then we'll actually be taking account of this operational carbon too. And then we have this extra bit here, what we call module D, and this is where we look at the benefits of any of these materials throughout the life cycle here that are being recovered, recycled. What is the benefit that actually brings? So it's like an extra kind of module piece of information that tells you about those benefits that you're getting. And again, if you use recycled materials here rather than using raw materials, then you get that benefit because they don't have anything like the same impact to manufacture them. So you get much lower impacts here. So that is what embodied carbon is. Life cycle assessment is basically doing exactly the same thing, but you're measuring a much wider number of environmental impacts, not just carbon. Why is it important? Jack showed you the 11% in terms of global emissions from construction. In the UK, there's lots of different figures, but somewhere between 7%, 10%, maybe even 15%. It kind of depends how much you're taking into account things like imports and how wide you go and how good the information is. But it's certainly a substantial part of our impacts, and there's really nothing, well, there is nothing at the moment that's limiting that in terms of the impact of buildings. Jack showed you a breakdown. I'm going to show you another one. This is for a house. Again, a lot of the impact here from foundations and the ground floor, the kind of structure for a house. You've also got the external walls, internal walls, and then the windows and the roof. And then this is MEP and services, so things like your boiler, the pipework, these types of things, electrical systems, and then floor coverings, finishes, paints, things like this. And again, in terms of the balance, this was a house built to above building regs, but you're still seeing that the operational carbon is a lot. And that again is why there's real focus on reducing operational carbon. Rightly, the building regs don't go anywhere like far enough, but we also need to address this embodied carbon. And studies where people do look at this, it's very often very easy to make reductions in embodied carbon of 20, 30, 40% without any additional cost, just because it's something that people haven't looked at, and there are lots of ways of making those savings. What are the benefits? So again, if you're looking at trying to measure and then reduce embodied carbon, it's very often sort of linked with cost savings. So there are one of the biggest ways of trying to reduce embodied carbon is looking at efficiency, not wasting materials, not using too much material, trying to get a material to do more than one job. And if you're able to do that and you're able to use materials more efficiently, then that will come with cost savings. It hopefully is a good thing in terms of meeting climate obligations. We are finding, we've done work with housing associations recently, and they're now being able to actually access much lower rates of interest if they're able to demonstrate that the housing that they're producing is really good in terms of looking at the climate impacts. So it sort of actually pays back in terms of getting money to build more cheaply. And it has benefits in terms of the circular economy, because again, materials, for example, that have higher recycled content or that can be recycled will generally also have lower embodied carbon, or it will reduce embodied carbon. At the moment, in the UK, or certainly as in terms of the individual countries, there is no legislation on embodied carbon. We have now got a lovely little green dot here in London, because the Greater London Authority, the GLA, has just had the Secretary of State give it permission to put its new London plan into effect, and that will require the larger schemes that the Mayor has to look at. They will have to measure and report their embodied carbon, and the GLA will be setting benchmarks for them to meet in the future. But in lots of other countries in Europe, in France, in the Netherlands, in Finland and in Sweden, they have regulation. They are required to report embodied carbon and to make reductions and to meet particular targets. and there are other countries, so Belgium and Italy, where they link to embodied carbon in their regulations for some of their products. And there are also lots of places in the States and in Canada, states where they are focusing on this and have requirements for either products or their buildings. So there are, I haven't actually put it, but there is a great resource called Embodied Carbon Policies that tells you all about the different policies that countries are using, or cities and states. I'm quickly going to run through how we look at construction products, because that's obviously what buildings are made of. So how do we do that? And the way that we do it is using life cycle assessment. But what we do is we have something called product category rules, which make sure that when we assess products, we're using exactly the same method so that the results are consistent and we can make comparisons. And the result of that is what we call an environmental product declaration, or an EPD. And these are the pieces of information that give you the data on the embodied carbon of products. There are now over 10,000 EPD that have been assessed using the European standard for construction products. And you can see how they've grown over the years. A lot of these are in France. So when I mentioned the legislation in France, it's a requirement that if you make any environmental claim about a construction product, that you have to have an EPD that demonstrates that information. So you can see that there's a lot here in France, and then there's another one further up here that's also French for building services equipment. There are, in fact, another probably 30,000 EPD that are using an international standard. Most of those are for concrete. In the States, there's a there are now just thousands of EPDs for concrete, because there are tools and ways of searching for them that make it now possible to actually try and find a concrete with a very particular environmental performance and technical performance within a certain number of miles of your site location. So we've kind of seen it really explode in the States, and hopefully at some point that might happen here. This is just to give you an overview of all the different types of products. There are a lot of insulation EPDs, lots of floor coverings, but pretty much now there is an EPD for almost every product. You do have to look for them, but there is hopefully an information paper coming out. I'll give you a link that will give you some ideas. In fact, there is an information paper that gives you those ideas. There is one coming that's actually talking specifically about UK products. I think the easiest thing is to have a very quick look at one, and hopefully this will work. So can you see an EPD icon?
That's great.
Excellent. Okay, sorry. Make it take up a bit more screen. So this is an EPD for UK produced brick. It comes from BRE. The important things to know about it: EPDs are verified, so it means somebody's actually checked that the data makes sense and that the PCR that I mentioned has been followed, so the data accurately follows the methodology. EPDs will tell you who's produced them. So this is for the Brick Development Association. It'll tell you when they're valid, so you know that they're relatively recent. And they also tell you what rules they've followed, who's done the work, and what they cover. So this is for 1 ton of brick. It's telling you all the impacts over the life cycle, and it's the UK sector average. So it takes data from all the manufacturers in the UK, and that's the proof here that it's been verified. You saw the list that Joe Jack showed you. So this, again, each of these are ticked, so it's showing you that it's giving information over the whole life cycle for the product. It's telling you that it's come from 99% of the UK brick manufacturers, 46 sites. So it's a really kind of an EPD with really good coverage. It tells you what a brick is. Maybe not that useful for a brick, but it is can be really useful for other types of products to make sure you've got the right thing, and explains technically the size of the brick, how much they weigh, what standards they meet. What goes into it for a brick is pretty easily basically clay, sand, and some inorganic additives, and how you make it. And you've got a nice picture there as well. So EPDs follow different formats. All the BRE EPDs look like this and are in the same order. Different EPDs in different countries will have different formats and different orders, but they will all give you this type of information. So once you know what to expect, you'll find it. This one tells you how long the product is likely to last and what's going to happen to it at the end of life. You've got this repeated, it's for a ton. And then where they got the data, who gave the data, how they collected it, and what tool they used, and basically that this one has it's included all the processes. EPD have to include kind of 99% of the impacts that where the manufacturing occur, and they're not allowed to kind of exclude anything intentionally. So that should also the same thing. This is the kind of meat of the matter, where you get the environmental impacts. And GWP, global warming potential, this is basically your embodied carbon. Okay, so it doesn't say embodied carbon, but you want to look for the global warming potential, and it's measured in kilograms of CO2 equivalent, and that's the same unit as embodied carbon. It is the unit of embodied carbon. So for this EPD, they've aggregated the impacts of extraction, transport, and manufacturing. So this is what we call cradle to gate. So 1 ton of bricks releases 213 kilograms of CO2. So that, if you like, is the embodied carbon of a brick when you make it in the factory. Its upfront carbon would be all of this impact here. So this is the transport, a typical transport to site, and then assuming a certain amount of wastage on site, and the impact of disposing of that or taking it to be treated and recycled and crushed, for example, for use as aggregate. These modules here, they say module not relevant. Basically, once you've put a brick into a wall, you actually don't need to do anything over a 60-year life of a building, so there is no information recorded here. At the end of life of the building, then you've got the impact of taking it to recycling and then waste processing, and a very small amount of it going to landfill, and then you've got the benefit here from being able to recycle it. There are lots of other indicators. I won't go through them because they're not particularly relevant to embodied carbon, but lots of other indicator results. And then at the end of it here, it actually describes these scenarios, so exactly how far bricks travel and what happens to them at the end of life. It gives you some quick graphs so you can see which bits of this, what's causing the impacts, and then it's got some references. So that's basically a very quick view of EPD, but effectively you want to look for the GWP information if you want to compare the embodied carbon of different products. So I'll go back to the slides, sorry. Oh no, here we go. Yeah. Oh, there you go. Just some tips about EPDs. So an EPD is literally, it's like a label on a piece of food. It just gives you the information on the impacts. It doesn't mean it's good or bad. So having an EPD doesn't mean a product is good. You need to read the EPD and look at other products to understand whether it is a good or a bad product. If you like, the worst product in the world can have an EPD. It's just going to tell you how bad it is. all the EPDs in Europe follow what we call it EN 1584. It's the European standard for products, EPDs, construction product EPDs. And if you use EPDs that follow that, then you're able to make these comparisons and use them together. Yeah, and you can only really make comparisons between products when you're looking at it in the context of the building. So you definitely can't, for example, compare 1 ton of timber and 1 ton of steel, or 1 ton of timber and 1 ton of concrete, because they don't do the same thing. You need to use that information and work out how much of each material you would actually need to do a particular job. So for example, if you were making a beam, you need to know how much that beam would weigh, and then you can use the data from the EPD to understand those impacts. So it's only, for example, if you're comparing 2 bricks that you can compare them on the basis of the EPD. And even then, if they're both for a ton and one of them's got a very different density because it's got lots more holes in it, for example, you need to take those things into account. There is lots more information on EPD at the Alliance for Sustainable Building Products at this website. So there's some briefing notes that I've written. And as I say, there will be some more coming on how to read an EPD and what EPD are available for UK produced products. Other sources of embodied carbon data, the inventory of carbon and energy is a database that Craig Jones produced as part of a PhD, and that he's now updated at Circular Ecology. And it basically, for the main core materials, so timber, steel, concrete, glass, gypsum, I think, he's used available EPD to generate typical values for common materials in the UK. So it's what we call a generic data set. And then for other materials, it's using older data, although he is in the process of updating that, and hopefully there will be better information, but I'm afraid not for this project. But this type of generic data is good when you don't know exactly what product you're going to be using. When you get to your detailed design stage, then it's really useful to start looking at individual EPD and try to find the very best product of that type. So embodied carbon for buildings, I've got a bit of time. The really important thing when you're looking at measuring and reducing embodied carbon is that the sooner you start, the more likely you are to be able to make big savings in embodied carbon. So this kind of embodied carbon reduction potential is really, really big when you're in the kind of planning and concept design stages. It gets much, much lower as you get through design, and when you're actually building, then it's really, really limited what you can do to reduce embodied carbon at this point. And then you've got small opportunities as you're going through the life cycle of the building to actually make kind of changes when you're replacing and maintaining components. But here is really where you need to start. So it's great because you're right at that point right now. So hopefully this is information that will be really useful. In terms of how we measure embodied carbon, so we have standards here. This is the European standard. It links with the standard that we've got for construction products. So the 2 lots of information kind of mesh together, and the information all uses the same module, so that you can just kind of add up the information from the products to get the building impact. So we have this European standard, and then if you like, this is the kind of UK implementation of it, which is developed by RICS, the Royal Institute of Chartered Surveyors. So it's their professional statement on whole life carbon, and this basically gives you all the kind of default values for how far to assume goods are materials are transported before you actually work out which factory you're going to get it from. You know, what to assume for the recycled content of steel, these types of things. So this is kind of a really good guide. And a lot of the tools, so the tool that Joe Jack is going to show you is kind of following this methodology. here again, you've got this breakdown. So you've got, again, the building is using the same modules broken down into the product stage, this upfront carbon. Then we've got in use and the end of life stage, and then this module D and the operational carbon. So your embodied carbon is kind of everything in here, and your upfront carbon is just these first 5 modules from module A. The other thing to know is probably too much information, but in upfront carbon, when you're looking at products like timber that store carbon in them, then that carbon that's stored is not included in your upfront carbon because you're not looking at what happens to it at the end of life. But in embodied carbon, it's included here as the benefit of the carbon storage coming into the building, and then it's released at the end of life. So I have got a complicated way of trying to show that in a diagram, but it's too complicated at the moment still. There is lots more guidance. So Joe Jack mentioned the LETI Embodied Carbon Primer. It's a really good introduction, and it's got lots of really useful information at the end about different materials and about kind of reduction strategies. This is a guide that I wrote for Welsh housing associations, for architects, for the people that are funding it, for the consultants that are working on it. This kind of got really, I hope, really useful guidance. And again, these ones, if you click, if you get this, I'm sure the slides are being shared. If you click that, it goes through to the document. The UK GPC's got lots of documents, RAP has some, and then the professional bodies. So I mentioned RICS wrote the guide that we use. This is the RIBA guide, which again uses that same guide. It's kind of how you implement it as an architect using the RICS guide. For structural engineers, the same thing, and here for SIBSE for services engineers. So again, these ones are all free. I'm afraid SIBSE make you pay, but you might be able to find it through your libraries, hopefully. And embodied carbon tools. There are lots of them, but lots of them are free. And if you're students, probably lots of them are even more free. Oh, that went wrong. So Joe Jack's going to talk to you about FCBS Carbon. There are eTool is free, and I hope I've got, oh yes, so the tool that Tim Martel is going to be talking to you about, the Passivhaus RIBA AECB tool. There are quite a few tools that are available in other countries but are in English. So Totem in Belgium, the government has paid for it. This is a bit of a recurring theme. In Germany, ELCA is also free, and the government paid for it. Tally is a really nice tool. If you use Revit, it's a plugin, but it uses American data. But there is HBERT, which is also really nice actually, and that uses UK data. So sorry, I should have gone to HBERT first. EC3 is another American tool, and it's got a really nice interface to try and find these concrete EPDs, and they've got increasingly more UK EPDs in there. So it's worth having a look, and if you can use it to calculate buildings as well, and that's free. LED is French, government, but you have to pay for that one. And One Click LCA, they have a free version that is called Planetary, that's available through UK GBC. So there are loads of tools, and it is just a question of kind of having a look and seeing what you like. And yeah, Ecolab as well. And oh, sorry, and in this guide for Welsh housing, there's lots more information about these tools and all the links to them and some feedback from people that have used them. In terms of reducing embodied carbon, I've got quite a bit of time maybe. There is lots you can do, and there is also, again, information in that Welsh guide. Building form and layout is a really interesting one. So Joe Jack mentioned that your facade is quite an intensive kind of structure, your structure, and then your facade. is always quite a big source of embodied carbon. So anything that you can do to kind of simplify to reduce the amount of stuff you have per unit area of floor, so that the more wall you have per unit of floor area, you know, the more you're going to have an impact. If you think about it, the worst sort of building could potentially be a sort of L-shaped bungalow, because it's got so much roof. You know, it's got 1 meter squared of roof for every meter squared of floor, whereas if you think about a 2-story building, it's got 0.5 meter squared of roof for every meter squared of floor. You know, if it's L-shaped, then it's got a lot more wall per unit area of floor than if it's a nice, actually the perfect, well, it wouldn't be, but the perfect building would be circular, because that's got the lowest or kind of surface area to unit, whatever the word is, surface area to floor area. But probably circular buildings are really complicated, and there's probably lots of wastage in making circular buildings. So from that point of view, nice straight-sided buildings with nice right-angle corners kind of minimize waste, and that's where things like modular design, you know, using the sizes that sheet products like plasterboard and wood panels come in, then you're not going to have to cut 5%, 10% of them off to get them in your building. You know, you're able to use them exactly as they are, and you minimize waste. And if you imagine if you make 10% waste, you've increased your embodied carbon by 10%, because the materials that you don't use or that are wasted, the impact of making those materials, that's part of your embodied carbon. So yeah, simple, repetitive, structural solutions. It's incredibly boring, I'm very sorry. But these are the things, I mean, to an extent, your buildings, well, they may get built. So, but yeah, the simpler your buildings are, it's likely that the better they're going to be in terms of embodied carbon. Resource efficient approaches, it's really, really important. This is much too big for the types of building you're doing here for houses, but things like coffered ceilings in kind of floor structures, where you're, instead of having a big thick slab, you're actually really using the concrete really effectively and openly putting the structure in where you actually need it. These types of solutions are really good. Things like that. It's really important to try and use the materials as efficiently as you can. Lightweight construction, two reasons why that's good. One, the lighter it is, the less material you're using, but also if your building is light, then your foundations can be light, and if your foundations are light, you've got less concrete in your foundations, and as we saw, foundations is a big part of your impact. So anything you can do to reduce the weight of your building will have a consequential impact in benefiting in reducing the foundations. So when you're looking at reducing carbon, embodied carbon, focus first on the hotspots. So do a quick assessment and look, where is the big impacts? Have a look at those there. When you've looked at those, then keep going and looking at hotspots, and see if there's something that you can do. If there's two things that have got big impact, is there anything that you can do that actually would affect both of those? The link, Jack talked about the kind of link between embodied and operational carbon. So the materials, the things, you know, your boiler or your air source heat pump, your heating system, the pipe work, all of these things have impacts, and there are benefits in looking at both of those. So things like, from an operational carbon point of view, it's a really good idea to try and minimize your pipe runs, and to really, wherever your hot water is, you want it to travel as short a distance as possible to where you're going to use that hot water, because the shorter the distance, the less heat that's going to get lost. And surprise, surprise, it's just as good from an embodied carbon point of view, because the shorter that pipe run, the less material that you're using for your pipes and insulation to insulate it. So these types of approaches have benefits for both embodied and operational carbon. But it's a balance. You need to look at, putting things like PV on your building will really reduce your the carbon associated with your operational energy, but they have a embodied carbon impact. So things like PV are quite intensive in terms of the impacts that they have in manufacture. So you have to balance that, and you have to there isn't a right or wrong answer. You have to kind of take that into account. But if you can integrate things like PV, so if you imagine if you're able to put your PV on your roof, and instead of having roof tiles, you've actually, your PV is your roof tile, if you like, then that's a much more efficient approach than kind of sticking your PV onto your, on top of your building afterwards. So those kind of things, can you make things do, as I say, more than one thing. Materials like timber, so timber is inherently quite a low impact material, and then it brings with it this benefit of biogenic carbon storage. So it stores the timber that is stores the carbon that it's sequestered whilst it's been growing. It's been taking CO2 out of the atmosphere. If you remember your kind of photosynthesis equation, kind of CO2 plus water makes carbohydrate, glucose, anyway, yeah. So it's the kind of substance, cellulose, the substance of timber. So all that carbon is stored in that, and whilst it's in your building, it's not in the atmosphere. So there is a really big benefit, and I've got a slide that shows that. So consider carbon storage. It's good to have that. My motto is more buildings with timber, not more timber in buildings. So don't remember the resource efficient construction. Do not put any more timber into your building than you need, but consider putting timber into your building. If that makes sense. Yeah, there's no point putting double the amount of timber in. It's not helping anybody, because there isn't, timber is a scarce resource, if you like. We need to use it as efficiently as we can. We want everybody to be able to have timber in their buildings. We don't want to kind of like steal it. And if you do put too much into your building, you're basically just using it inefficiently, and your impact will increase, because timber has an impact. There is an impact in transporting it, in processing it, in kilning it. So you're not sort of helping by putting more timber in than you need. And lastly, think about how you can take your building to pieces afterwards and use it again. Use the materials in the most kind of the best way possible. So the worst thing you can do with a building is kind of hit it with a wreck and bill and just get left with a lot of rubbish that, yeah, possibly you can use it for kind of fill, but that's really the kind of downcycling in the worst possible way. If you're able to deconstruct your building so that you can reuse components and whole assemblies, then that's absolutely brilliant. Just very quickly, can you see the whole slide? Because I've got a bit that covers it up and I can't move it, but there are targets. So there's targets in the RIBA 2030 climate challenge, and then also in LETI, and I think you're working to the 2030 climate challenge targets. So you need to try and focus on that. But we have done some, you'll see in the Welsh guide, we did lots of case studies. It is quite hard to hit that 300, particularly, well, it is very hard if you're putting a lot of things like PV and batteries, for example, into your buildings. So that's, again, it's a really good idea if you can minimize the energy demand that you have. If you really focus on that, then you will need less PV and potentially less battery to actually operate your building, and then you may find it easier. So it is a real challenge, this, but it would be really good if you could be getting these kind of scores. Embodied carbon and timber, so I've talked a little bit about it. This just kind of explains, so basically each meter cubed of timber includes, it basically sucks up 1,000 kilograms of CO2, and it releases quite a lot of oxygen as well. So it's storing just over 250 kilograms of carbon within it, but a ton of CO2. So yeah. And as we say, if you put it into your building, then it's basically stored in the atmosphere for the life of your building. We say 60 years, might even be longer than 60 years. And at the end of life, it's even quite likely that it could come back. So for example, things like structural timber can be chipped and put into chipboard. I mean, they could be reused as rafters and beams, or they can be chipped and put into chipboard, for example, and then used in furniture or flooring, something like that. And then they've got another 15, 20 years potentially in a building. So it is really good idea if we can do that. And a typical 4-bed house can be storing nearly 15 tons of CO2. So this is using timber efficiently. And just to show you that the benefits, so this is a study, this is not housing, but this is an office building, compared concrete, steel and timber. So you can see that for this building, the timber does have a lower impact at the beginning. This is when the CO2 is released at the end of life, but it still actually ends up with less CO2 over the lifetime. And because of this benefit from the carbon storage, it's got a much better impact here. This is actually in terms of the actual amount of temperature change that you get from that CO2, and the fact that the CO2 is lower right at the beginning is a benefit that you see here in a reduced temperature change. So it is a really good idea to be using timber with its carbon storage potential. There we go. So good luck. Think about what you're going to do, design well, then assess it, review what you've got, look at the hotspots, try and reduce it, and then just keep going through that loop, and hopefully you will achieve your target. So thank you very much.
Thank you, Jane. That's really interesting. I mean, it showed us just how much detail there is. I mean, I had a couple of takeaways that I'll just flag up there. One for me, I was really interested to hear you talk about the simplicity of buildings, because actually the simplicity of buildings has real advantages for operational carbon as well. And you know, all you've got to do is look at some of the award-winning passive house schemes out there to see that actually simple buildings aren't boring. They could be done exceptionally well. And the other thing that you highlighted, which I thought really resonated with me, was the importance of collaboration with M&E engineers and structural engineers, and how this is a real team effort to make real inroads into embodied carbon. And that's one of the great reasons that you know, these design teams running this this competition. So I look forward to seeing some of the results. So we're now going to jump back. Thank you, Jane. We're now going to jump back to Joe Jack, who's going to give us a look at one of the tools for calculating embodied carbon. And if I can hand back to you, Joe, you take it away.
Yeah, thanks. So I think you should all be able to see my screen. Is that all coming through? You can see I got back to my orange glow. I'm going to talk about FCBS Carbon. I've got some slides to start with, and I'll just do a kind of live demonstration. Tim is going to talk about PHribbon, which is also excellent as well. So it's just a kind of option. I would say I'm going to try and flip through the slides as quickly as possible, because I know you're all desperate to see a man fill in a spreadsheet for 20 minutes. I'm sure that's exactly what you're all aiming for. This is FCB Studios' route to net zero. This is what keeps me up at night. by 2025, we are aiming to have all projects done on site being net zero operational carbon. And that gives us a bit of time for them to be built, and it gives us a bit of time to go in and fettle with them and make sure they're all kind of working properly. But as part of that, actually, we were really struggling just to understand carbon in our buildings, and we're a pretty big practice, and we've got a long history of this. We sort of realised we needed something else. It couldn't just be one person. We had to distribute something that really kind of helped us along. And we were trying to work out what kind of scale is it? Do we need another person, etc., etc.? And this is what was in our pipeline last year. So you can see we've got quite a few projects, quite a few at the start. So we've got a few down here and quite a few being built on site, which is great. And Jane showed the kind of inverse of this graph, saying the impact of decisions at early stages. Next, I'm showing the opposite, saying actually it gets progressively difficult. And also, when I say difficult, what I really mean is expensive. You can always make changes down the end here. We can always swap stuff out. Nobody will thank you for it. The contractor will probably try and hit you with a counterclaim or something like this. The client will be really upset, all of your kind of design, and you end up going back to the start again. So what we're really saying is these are your RIBA stages. These are the stages we can make changes: 0, 1, and 2. It's where it's cheap, it's where it's efficient. But this is also where we have least kind of design team, if you like. We're kind of out on a limb. As architectural practice, quite often stage 0 and 1, we might not have a design team. But already by the time we get to stage 2, we've probably got some massing. We've probably got an idea of the kind of size of the building, scale of the building, the form of it. We know what we can get through planning. We know what will make a bit of cash for the client. Everybody's kind of happy. So we have about 40 projects a year to really try and work out. And from a detailed point of view, establish the embodied carbon and the operational carbon. But we can't do it. We don't have models. We don't have a BIM model at stage 1. We don't have a bill of materials. So Jane showed you how to calculate the embodied carbon of a building by taking an EPD and multiplying it up. We don't know what we're multiplying it up by, let alone what the product is. And it kind of put us in a bit of a funk, because we need to have all of that detailed design done really quickly. But at the start, the more decisions we can make at those early stages that are informed and have some element of carbon within it, the better our decisions can be. We always need to have a sort of an element of sustainability or carbon attached to it if we're going to hit our zero carbon aspirations. And it is kind of interesting when you start to think about it like that way. I did another presentation of this kind of version where I worked out that if we just did two different massings, we'd have about 108 different design typologies to analyze, and that's just 2 massings by the time you've run through all the iterations. So it becomes embuggeringly difficult, I think is probably the term. So instead, we've got a kind of standard construction library build-ups. We're an efficient practice. We do, start from previous projects and take those forward. And we can kind of actually guess what's going to be in the building once we've got an idea of it. So we have this algorithm, which is what FCBS Carbon is. It's a series of algorithms that just creates that bill of materials for us. And then from that, we can apply it to our construction build-ups that we've got kind of standard, and somebody else has gone through and run through the numbers. And by somebody else, I mean me. I've gone through and created all these things and tallied them all up and said, this is a standard wall of this is a standard floor of that. And we did it for 3 reasons. We made this tool. One was just to kind of record the details of the projects. We wanted to know how we were doing. Kind of straightforward. Seems like a simple question, but it's kind of difficult when you've got 4.5 offices, 200 people. Keeping that going is quite tricky. We really wanted to be able to estimate the whole life of our projects. But also, I think third is to understand how it works. We've got a long history of sustainability, and that's absolutely great. But we're always trying to keep on top of these things, and we need to be able to educate everybody in the practice and let them find things out. It's great for me to talk and tell you, you should use 70% GGBS for your concrete or whatever else it is. Actually doing it, you'll find out so much more. So I needed some way of enabling the architects in the practice to do it. And I realized that people didn't really like BIM or Revit, and they didn't really like all these kind of plugins for tools, and I'm not the greatest developer in the world. So I made it in Excel because everybody loves an Excel sheet. And the kind of key thing here is that it's not ridiculously accurate, it's kind of fine, but we need to understand the direction and magnitude of changes when we make a design choice. So if we go from, going from a basement to having an extra story on top, is that better or worse? Actually, it's quite a difficult question to answer. What happens if you change the floor-to-floor height by 300 mil? What happens if you change the amount of glazing? So all these things kind of fall out of it. So this enables you just to understand whether it's better or worse and kind of by how much. So it's got 5 real pages to it. There's a kind of bit about project details. There's a bit about operational energy and embodied carbon. There's a couple of outputs. One's a kind of overview, which we think is kind of useful, and you can kind of print it off and stuff in a stage report. There's a detailed one, which allows you to kind of tinker in it and have a little bit more luck. There's a kind of consistent color theme. So yellow things are things where you need to put in data. Dark blue, gray are kind of calculated. So this is the kind of main sheet. I can I'll show you, I'm going to run through it in a second anyway, so you'll kind of see all these kind of bits and pieces, but just make sure you fill in everything on this first sheet, particularly year of completion. A lot of people skip year of completion. It's really useful. We do kind of forecasting of energy within the background. So if you don't have it, we don't know when it starts and it kind of breaks down. You can't do projects in the past is the only other thing. It's kind of live. So we input operational energy. This is the least smart bit of the spreadsheet. It's got a nice snazzy color scheme, but that's about it. It's got some nice graphs as well, I suppose. You just have to manually pick it. There's a bit here which is benchmarks, and it'll tell you what we think the industry is doing, and this is based on kind of CIBC, or in this case for housing, it would be based on a bit of study done by Etude, just showing kind of where you are. Now we have a kind of target that we're going to be aiming for. We're all aiming for 35 kilowatt hours per meter squared per year because we're all going for the kind of LETI targets. So that's a nice easy win. We'll pop that in. The very fact that it's very difficult to get to is another story. We'll come to that at some point. And this is the kind of clever one. This is the one where all the stuff happens. You kind of have a bit here, which is you put in building parameters, sort of general global parameters for your building, if you like. And then down here, you can kind of select all your materials, and I've got a kind of preset list. And you can say whether it's new, whether it's existing, so you can use replacement bits. You can say if it's old, how old it is. You can say how long it's going to last for in terms of component life. You can use this adjustment factor, which for all intents and purposes is a fudge factor, which makes it kind of work for your building. And design for disassembly. So if you're going to have this kind of design for disassembly, we can kind of start to capture those elements and represent them as a benefit beyond the system. Just so you know, where we say if your facade is going to be, ceramic cladding or whatever else it is, there is a whole model that sits behind it. So we have ceramic cladding, but we also have the steel framing system that holds it in place, and all those kind of bits that hold it back to the wall. So all of that comes in there. So whenever you pick a material, there's actually a little bit extra within there. And these are from ICE data. So Jane mentioned the inventory of carbon and energy from Greg Jones and Circular Ecology. We've used those mostly. Where we don't have a good bit of data from there, we've used a particular EPD. But for all intents and purposes, it's generic data. The impact of that is if you model your actual building and it comes out slightly different, it will do. You've got the real quantities, you've got the real products. It might go up, it might also go down. So just always kind of caveat that. This is a really useful table. It should be in the guide, and I should really put it in there. I've just updated it, which is kind of frustrating, so I'm able to do that tonight. When you change parameters, which are these the parameters here, these are the bits it impacts. So when you change these, just make sure you're seeing. So if you're thinking, oh gosh, I wish I could change the embodied carbon on my floor, check the GIA, check the footprint. These are all things that will factor into your floor slab and your joisted floors. So have a look at that. It's kind of a useful tool. We'll send these slides anyway, so you'll have a look. This is your main output. I won't dwell on it for too long. We can look at it properly, a live one. This is your energy. This is your embodied carbon section. Note you've got the RIBA 2030 challenge bars at the top. The dark bar is the one you should be using. The light grey bar is one that includes things like sequestration or renewables, and there's the kind of exciting, fun stuff that we as architects like to include to make it an easier job for ourselves. This bottom left one here is about whole life carbon. So you can see what the difference is over 30, 60, 90 years and 120. And there's some kind of indicative figures about offsetting carbon if you want to plant some trees. But this should be 0, so it should be fine. And there's a bit more of a detailed output here, so you can see by module stages what's going on. The more astute of you will notice that there's biogenic carbon here, but there isn't biogenic carbon up here. When we made this, took the decision that you wouldn't be burning bits of timber at the end of its life, and it'd all be getting reused and passed on to the next kind of places. It's not technically correct if you're following BSEN 15978. You should, this lump here should be up here. So with that kind of caveat out of the way, it's mostly fine. I quite like this graph as well. This is just showing you all these kind of life cycle replacement aspects. The red line there is your kind of worst case scenario. So that is showing it's using the current grid factors for your energy. It doesn't have any renewables involved, and it doesn't include any sequestration. If we include sequestration, this is that kind of green line, so it starts a bit lower. We have a decarbonising grid, so the lines split apart. And also we're able to include things like renewables, so PV panels and that kind of stuff. So with that out of the way, that's my prompt to open a spreadsheet up. In fact, before that, now I work for a leading architectural practice. Well, I'm actually an engineer. You would never tell. This is my submission to the competition. And you will also quickly see that I'm absolutely terrible in SketchUp. So this is, it's on a 6x9, kind of a familiar size. 3 stories, it's 3 meters high per floor, kind of fine. I haven't put any windows in, but I didn't really know what to do with it. There's no roof lights, PVs or anything. Maybe it's terrace, maybe it's not. There you go, kind of great, isn't it? I mean, I should do this for a living. But when we get to the FCBS Carbon website, so I presume you can all still see this. I put in some things here, so I put in a project number if you want to use that for your records, and project name, the terrace, just I've called it my terrace. I've put it stage 1, I reckon it's going to be finished 2023, that's when it's all kicking off in Sunderland. Here you can choose the sectors. Now the limited one we send out only has housing and offices, others are in development, and you can kind of choose what it's going to be. Is it going to be a single family house or a flat or a multi-family kind of thing? You can kind of get an idea, and you can kind of swap and choose. It doesn't make a huge amount of difference for some things, but things like predicted energy use and grid sizes, it might make an impact. My house is going to be 130 square meters. There's no particular reason, it just is. I think it fits into that building form. I probably should check that. And some kind of bits. You can put some environmental objectives in here. It's worth putting these in. It's part of the RICS guide. Is actually you should have a bit of text in there to tell you why you're doing these things. So input energy. So it comes in looking like this, and I'll zoom in a bit so you can actually read it. These are your sector benchmarks. So if you remember, LETI target was 35. This is an innovative building according to current building standards. Not building standards, but built buildings. This is actual data. We'd be in about 58 would be our kilowatt hours for total energy. Ooh, it's going to be a bit tough, isn't it? Anyway, so we're going to aim for 35, and I'm going to shove it all in regulated energy use. And it kind of doesn't really matter where it goes. You could chuck it in any of these. I avoid putting it in the non-electric because that's technically gas. I'm going to make a little note for me here. Estimate. A couple of question marks. I don't know where it came from. It came from LETI. I do know exactly where it came from, but there you go. And down here, you can add in things like PV power and generation. So now if you go to, there's a website called PV Watts. If you download FCBS Carbon, it comes with a guide and it tells you where you can get this kind of information from. I reckon, and we saw that little table we had before, I reckon we can probably get, I don't know, 20. Finger in the air kind of guess. We can always come back and change this. It's just a number. No, this is per meter squared of the building GIA, not per meter squared of panels or anything. And we can see how we do. So I'm hitting the LETI, the RIBA target. And if we include renewables, we're absolutely smashing it. Winner. So onto the fun stuff. So I'll just quickly fill this in. So we need to fill in the perimeter. So it's 6x9, so it's 6 plus 9 plus 6 plus 9. Oops. Oops. The building footprint, it's 6 times 9. The building width, we were just looking for the thinner side of it. If your building's wedge shaped, just take an average. It doesn't really matter too much. We're just trying to, for bigger buildings, it becomes kind of useful. We make a grid off the back of it, so we'll call that 6. Floor to floor height, that was 3. We had a number of stories above ground. We had 3 there. No, floor to floor height, I'm not including the roof. You might want to, you might not. It depends how it kind of works. You can just put an average in. It'll help you kind of with those guides. Number of stories below ground, 0, and I don't know what to do for a glazing ratio, so we'll just pick a number, 30%. That's it. That's the kind of global variables. Now we get into the fun bit of just choosing materials. Now, some of these, because this is for offices and for housing and big housing, you have a whole raft of things that you may or may not use. So we're not going to have piles because it's only a small house. We probably won't have pile caps. Capping beams is the one caveat. We might want capping beams. So this isn't really strictly correct, and this is something we're still working on. It's still beta testing, I must stress that. We're going to use foam glass blocks. What this capping beams do, they run around the perimeter of the building, and also they run in a kind of zigzag across it between all the capping beams. What we're going to do instead is we're going to use foam glass blocks as a kind of insulation to build it up. So we're going to use that. That's for domestic only. We're going to put a raft in as well. No, I don't think we will. I'm going to put in a beam and block system. So in the lowest floor slab, beam and block. We don't have basement walls, so we don't need to do that. We're not going to have a raft because we're going to have that beam and block. Some ground insulation, let's go for some XPS. We don't have a core, we don't have any columns, we don't have any beams. It's only 6 meters, we don't need any of that kind of junk. Secondary beams, floor slab, what should we have as a floor slab? Precast reinforced concrete, why not? What an abhorrent thing to use, but why not? And we're going to go at the top as well. We've got a roof, what should we use? I don't know, let's use steel concrete composite. Oof, horrendous. So this isn't a real building, obviously it'd be changed. This is assuming that the roof is going to be flat. Obviously it's not going to be flat, it's going to be slightly bigger. So we can start to use the adjustment factor here. Now you could do this properly if you assume your roof is flat and then work out the area of your roof. You can get a kind of ratio. I'm going to guess, because I don't have time, but 130%. Pop in some insulation, so some rock wool, roof finishes. How about a zinc standing seam? Why not? And we're going to have block work with brick, and we're going to have some rock wool. Now, obviously, we're going to have triple glazing. We're talking about low energy. Some lovely aluminium window frames. We're going to have some plasterboard and steel stud partitions. We're going to have a plasterboard ceiling, carpet throughout. Now, Jane mentioned the services. So getting decent services figures and actually predicting is kind of tricky to do. Still kind of new at it. This just takes a bit of a flyer, so it gives you a kind of number in here. They'll tell you here. So it's medium tech, boilers or an air source heat pump, probably MVHR as well. Maybe it's about 60. It's a guess. It's more of a placeholder for when you actually know it. So this column here is your assumptions, and it tells you all about what we've assumed within your building. So you might find it's not quite right. So you can always go in and change it. So say our slab is 150 mil. Maybe our slab's going to be 175. So in here, I'm going to do 175 divided by 150. There you go. So we've got a kind of uplift, and we can see how my building's doing. Oof, it's pretty bad, isn't it? Let's have a look here. So when we see in here, and I'll just zoom in so you can see it. So our total carbon is 670. Not surprising, it's using terrible materials. And we can see how we're doing up here. So this is our operational energy, looked really good. Embodied carbon side, oh, way down, not even hitting the 2020 challenge. So kind of bad. When we look at these other bits here, we can see 60 years, you know, oh, whacking great lump. What you will notice, these are actually pretty flat. And what we haven't done yet is look at actually kind of replacement cycles. So it's worth going back through. We'll pick some of these. So a beam and block floor, I'm not really sure how long beam and block floor, so it's 80 years and 80 years and those kind of bits. But if we start to think about some of these more key bits, so if we think about carpet, for instance, maybe it's 15 years, you know, good quality carpet. Services will last 20 years, probably. You kind of triple glazing there. Good glazing will last 25 years. it tends not to last much longer. It might last 30 if you're lucky. It just kind of falls apart. It's a bit of a shame. And we'll say that, tell you what, our aluminium windows will survive 2 replacements, or 1 replacement, 1 install, 1 replacement, and then they'll be going in the skip. Our other bits, I think they're probably going to last quite well. Maybe our zinc standing steam will last 75 years, as a guess. Now, there are tables for this, and it's kind of tricky to predict. It's something we're looking at, is actually how do you help with those kind of predictions. And you can see all of a sudden, what was a very flat bar chart has gone very, you can see it picking up very quickly. And if we look now up here, we're way off the end. So we've obviously picked the wrong materials somewhere down the line. And if you look at this, you can see all those little replacement cycles and little lumps and bumps going ahead. But the fun with this is we can start to tinker with bits. So maybe I want to, if I wanted to do party walls, for instance, external walls, we'll do facade, and we'll do some party walls down there. We'll do some blockwork party walls. And I'm going to say that's going to be 50% of the walls is going to be that, and then 50% is going to be wherever it is, brick facing. We said about the glazing ratios. Maybe the glazing ratio is going to go down a bit because we've got going to have party walls. It's going to be pinned in. Does make quite a difference. And I think that's about those replacement cycles. It makes massive differences. Then you can tinker with all these bits. What if you went from blockwork and brick down to, say, something quite nice like a timber cassette panel with brick? We start to see these things come down quite a bit. So these are all make little changes. You can do design for disassembly. So if we did our timber cassette panel, make that design for disassembly. Now go back to our output 4. You can start to see these things filtering through and coming out at the end. I would say that Jane's point about natural materials make the biggest difference, and that is entirely true. The less products you can get in there, absolutely the better. So if I get rid of this and go to a timber pitch roof. So the timber pitch roof, just so you know, actually already has a pitch built into it. So I don't need to put that in. In fact, if I scroll to the right here, it's at 912 pitch. So you can kind of check whether that looks about right. There's a bit here you can add your notes in. And there you go. So that is the quick overview of FCBS Carbon. So in 20-ish minutes, I managed to input all the data for that project and actually then start to really interrogate these things and really work out how this works. And you can imagine we do this with design teams. We sit down with clients, we sit down with structural engineers. We say, look, is this right? Is this wrong? What do you think? What about this material? Okay, we can make it bigger. We can, we can flippantly add a story on. Does that happen? We can add a story. We can make it 2 stories. Now, the only thing to be careful of, if you do something like that, we don't change the floor area. So just be careful when you say, oh, we're going to add a story on. Well, okay, you can, but it doesn't make a difference. But you can say, what's the impact of 300 mil? So really super quick. It's all about making rough design decisions in an informed way and getting a good idea about how it all works. And if I go back to my PowerPoint, you can download it from here. It's updated today, fresh. It's all very lovely and exciting. So have a go. Feedback, any information you find, good, bad, whatever. We'd just love to know how you're using it so we can make it even better and better and better. So there you go. I'll hand back to Adam.
Thanks, Joe Jack. That was really interesting. I was just saying to Joe at the start of the session that actually we have somebody in our office who's looking at embodied carbon tools at the moment, and I know that they've been looking at your tool, and I've heard some good things about it. And of course, it's free. It's free to download, which is fantastic. It's all about sharing experiences and small practices like ours. Really grateful to the sort of knowledge that bigger practices are sharing. One of the things I thought really interesting about what you were saying there is that the tool is really important at a really early design stage. And in terms of engaging with clients, that's it's fantastic, because I don't think a lot of clients, well, perhaps not in the Northeast, I don't think a lot of clients have really got their heads around embodied carbon. A lot of architects haven't got their heads around it yet. So just being able to, even if we're using the tool to stimulate those discussions about what sort of construction method we might use. It's really interesting. I mean, I was thinking there about the story we've all been told about the 3 pigs and about how we need to move away from straw and start building in brick. And we're just going to have to undo all of that, aren't we? Right. So we're coming towards the end of our presentation. We have one presentation left from Tim Martel. Just a quick reminder to everybody, do leave some questions in the chat. I've been picking them up as they go along, and we'll field those as we get towards the Q&A session. But last but not least, Tim, welcome.
Thank you very much. So I'll just share my screen.
That's looking good, Tim.
Good. So I'm going to talk about 2 tools which are quite similar, a basic one and a bit more involved one. Actually, I don't know if we can count hands. People put their hand up on Zoom. How many people have actually used PHribbon or may possibly use it in the future? Do we have any? Oh, Joe Williams. Have we got, how many hands? I can't see how many hands, but can anyone say how many hands?
So at the moment we have 5 hands up.
5 hands, so more than 0. That's good. Okay.
6 now.
Oh, 6, right. Okay, so it would be worth talking about that bit. Right, thank you very much. That's really great. So I'll be talking about the process. Just before I start that, I'll be talking about these 2 tools, and the majority of this talk is actually a live demo, so nothing could possibly go wrong. I'm going to just go through briefly the some of the thinking behind it first. So here we've got whole life carbon assessment, the RICS document where all this comes from. Should be aware of that. Both tools use follow very closely this document, and that's divided into all these parts. If we were to graph what we get from sections A1 to A3, if we were to graph that, we'd get a graph I'll show you in a second. But there's also other stages. There's the construction process. So this is the manufacture of the products. This is the construction of the building. Then we have use, end of life, and beyond the system boundary D. So if we graphed just A to 3, we would see for a low energy building, I mean, I'm involved in Passivhaus, so my main interest is Passivhaus, very low energy buildings. And if you had 3 different variations of that, looking at A3, then you would get in the masonry one, this is U values all being the same. So it's the same insulated building. You'd get this for a masonry, this for a SIPS, and this for a timber and cellulose. So with a timber and cellulose, you get some emissions. This is above the axis, but you also get some carbon stored. So that's below. And we have a breakdown of all that on this other graph here. So what happens when we actually add construction? Well, that's interesting because it adds a little bit there. And if we added the rest, that's use and end of life, we'd get all these here. And what the interesting thing is this end of life makes quite a big difference. That C, well, it makes the biggest difference for timber and cellulose. But what's important is not the height of the bar, because the height of the bar in this graph is just emissions. We've also got carbon stored to take into account. So the overall figure is that side plus that side. Well, I suppose negative in a way, but if you add those 2 together, you get 135 for this one, whereas it's 201 and 214 for that one. So although they look the same as far as emissions are concerned, or similar, they're actually, even this one is quite different, and that's mainly because of well, it looks different. It's different because of this bit here. So I'm going to just leap from there to the first little tool, which which is here. And so both the tools use all those stages, and they calculate all those stages. So in this very quick example, I'm not going to spend too long on it. In this very quick example, in this first one, it's just quite a simple spreadsheet. So
Tim,
yeah.
could I interrupt you for a moment?
Certainly.
Would you move the microphone a bit, just up a little?
Right.
Just that's much coming in much louder now. Thank you.
Oh, okay. Sorry. Right. Okay. Good. Okay. So with this first one, let's just make that a bit bigger. You would select a material from the list, and it's a big long list. In fact, it's a huge list. It's the list comes from this tab here, so there's literally hundreds of things in it. But you could select materials from there, and then you'd need the quantity. And so you've got a number of columns here which you can use to produce that quantity. When you select the material, it gives you the units. So you know you've got to produce it in meters cubed. And then you have to measure from somewhere where that meters cubed, you can, there's a formula here which it gives you some standard formulas for working these things out using these cells here. And then we've got to take into account transport to site, again using RIC standard assumptions, local, national, Europe or worldwide. If you change one of these, then it'll change the distances of each one. So if I change that to national, it changes the distance there. But you can also change that if you actually know the distance, you can adjust that. And then it gives you the results in terms of A1 to A3, A4, A5, B1, B4, which is replacements, C1, C2, C3, C4, and all these other things as well. So then you start to build up a graph of that, and it's really a rather basic graph. It's only showing you a breakdown of the percentage of each. If I just take you to another one, hang on. Here's one that's finished. Then if we looked at this, then we've entered all the materials, and that takes a little bit of time. We've got windows here. The list for window, this only actually shows you the windows because this is the section for windows, and then you've got different types of PV, different types of other, and you can select actual products, so boilers, copper piping, doors, that kind of thing, and heat pumps, MVHRs, MEV systems. And so I think it's fairly clear what we're getting out of this. What's interesting though is you can actually pinpoint where is that CO2 coming from, and we've got an overall breakdown here, but you can actually see from the shading in here where that's coming from. So quite a lot of it in this case, if I reduce that down, I've just minimized the view slightly. So now we've got concrete there, and you can see quite a lot of that CO2 comes from the manufacture of that concrete. And here, the totals, I left you a little bit of a further calculation area where you can just summarize. You might want to know what's the summary for the floor or what's the summary for the walls. This is designed to give you a whole building, and there is some other information you've got to enter. So that's a fairly basic one. Now, what else could you have? Well, it's a great thing to be able to use the actual software package you use for the energy modeling. I'm going to close those for a moment. If we go to PHPP, as some of you will know, is quite a large program. It's designed to do very accurate energy modeling for Passivhaus. And here we are in a PHPP. And you can also do energy calculations within, sorry, you can also do embodied CO2 calculations from within the PHPP. It's a spreadsheet, but there's this software that I wrote for the AECB, which is called PHribbon, and this is it here. It's in there as a ribbon, just like any other ribbon. It gets installed as that, and the embodied CO2 is that button. And if we start a new cradle to grave calculation, now I'm going to be mentioning I-beams, and just in case you're not familiar with what those are, timber I-beams, there's one in the background here. And what this is, it has the strength of a solid piece of wood, of a, say, a rafter or a joist, but it uses much less timber. And incidentally, it also has much less thermal conductivity from one end to the other. So it's used quite a lot in low energy buildings, passive houses. Anyway, notice that we'll be talking about the section. So if you had this installed, if you were over here and you took a section, it would be all the way through insulation over here. And then if you took another section through here, it would be timber and then some insulation and then more timber. And if you took a section through here, it would be timber and timber and timber all the way through. So anyway, I just point that out because we'll look at it later. So I'll start a new calculation and we'll add some materials. And what it will go through is it will just match up. Now the other software didn't do that. So this one, you click on the material, and this list of materials is already in PHP. You've already used it for the energy calculation, so might as well use that. That's the majority of the data entries from there. So you can select a type of plaster there, and then we can just carry on with and let it match up materials. Let's see, that one 34, that will be that one, and then brick, and we can use that one, and then we go to the next U value and it'll start putting this one in. I don't want to run out of time, so I'm just going to cut to another little bit. If you have a complicated section like this, and this is important because complicated sections where you've got 81% of it is cellulose, 15% of it is that section I was talking about, I-beam, cellulose, I-beam, and then 4% of it is this other section, this third section. You can actually do that really quickly in here. You can say this section 1, we can add these numbers together and get the whole thickness of all that one. That's all cellulose, treat that all together. You can then write that cellulose again. Actually, I should have selected it there. It's volume filling in walls. Write that, and then this I-beam here, add that section there, and then you can add this section together as well. So you can actually do it really quickly, even something complicated like that. And like that, there are other things you can add: windows, PV. You can add finishes. So it gives you a context-sensitive menu for adding the external things which aren't actually in the PHP. Some things like the roof covering, the internal walls, the intermediate floors aren't in PHP because they're not a thermal element. So it will help you add those. And then you've got heat pumps, anything else, heat pumps, cables, MVHRs, all that kind of stuff. If I cancel that, close that, I'll show you one which is finished. And what you get out of it is this. Now remember, we're in the PHP here, so anything we change in the thermal side of it will be immediately reflected in the embodied CO2. And it's also, what it's worked out then is it worked out the embodied part. This is the embodied part here, separated out into all these different sections. We're looking at 4 different scenarios here. We can have up to 4. Actually, I've cheated and I've rigged it so I can have a 5th on here, but normally it's 4. And this is, incidentally, this is a heat pump without a retrofit versus 4 different types of retrofit. So that's quite interesting in itself. Now, if we actually had the gas-powered original, then we would be showing an even more extreme graph where it would be off the scale. So it's really interesting to be able to show the operational side as well. And you get a summary there, and there's also you can also show a RIBA tab. And like that, like the last one, you still have a section at the top where you can see where the CO2 is coming from, manufactured materials in that one. There are, you can look for the redder ones are worse. This is a heat pump here, and the greener ones are better. So that's the 2 different versions. So this is called PHribbon. I suppose I should just finish off by saying there are examples of this. There's plenty of examples, and this is the sort of thing you get if you do others. I'll end there. Thank you very much.
Thank you, Tim. That was really useful. Tim, do you just want to say where your tools are available?
Oh, I suppose so, yes. If they look there or contact me, and they're available on the AECB. Well, I wrote them for the AECB, so they're mentioned on the AECB website. The standalone one isn't yet available, will be very soon. But otherwise, you can look at the AECB website or this one. This is where you actually buy it in actual fact.
Fantastic. And if you get a chance, as we continue on, Tim, perhaps you put a link for the AECB in the chat.
Oh, right, yeah.
Can pick that up if they're well, look, thank you. That was that's really interesting. It's interesting to see how Excel seems to be the go-to tool for for embodied carbon calculations. I mean, what I thought was really interesting about that was just to see the sort of hotspots of where carbon is sitting within the construction of the building, and it occurs to me that by making choices around the carbon how we're designing buildings, we might actually, not only are we cutting down carbon, but we start to drive change in the parts of the industry that are more carbon intensive. Perhaps we'll see concrete suppliers switching to more more renewable methods and so on. So all good. So Tab, if you're still there, I think if it's okay with you, we'll move to some Q&A.
Yep, I'm here.
Yeah,
thank you for a fabulous range of speakers.
Yeah, it's great. Tab, I've been pulling out questions as we've been going through the session, and I'm happy to table those. But
you carry on. You're doing an excellent job, Adam. I'll leave you to it.
Yeah. Well, as chairperson, I get to choose my own question first, and I had one that I picked out, Jane, from your presentation that something just really sort of piqued my interest, and that was your reference to recycled materials. And I just wondered whether there was any established market for recycled materials, whether it would be realistic for students doing a competition like this to factor recycled materials into their schemes?
There are some. It's not super established, but I think up in the northeast you actually got a steel. There's a company that sells, it recovers steel from pipelines and things like that, and from buildings as well. So there's that you can buy reused steel from them. That's where the steel that was used in the Olympic stadium came from. There are kind of reclaimed products. Bricks is one of them that's quite often quite easy to get hold of. And there's even an EPD for Danish recycled bricks. Don't get them from Denmark, but it'd be the same impact. But Yeah, I think you need to have a look. There are a couple of forums. There are a couple of kind of places where you can try and find materials. Yeah.
Fantastic. And Jane, whilst we have you on, perhaps something you could just clear up a question that Charlie Law asked earlier on, which was the importance of getting the functional units correct. There was a comment made that there is, I think you actually raised it, that there are a range of different units made, and if people are looking at EPDs, they need to understand what that is.
Yeah, so some materials, so concrete, for example, the declared unit, the EPDs come per metre cubed, and the same for timber, because that is the way that you procure it. Bricks, it comes per tonne, because the impact of the brick is to do with the weight, and the air in the brick kind of doesn't have any impact. So you can get different volumes of brick, but they'll actually have the same mass, and it's the mass that is the driver of the impact. So the way that the units are chosen is normally a unit that kind of directly relates to the impact and gives you a good kind of approximation. So Joe Dack's got a question.
I was just going to add on to that. We've been entirely stumped by getting the wrong units occasionally, and I still think insulation has the toughest unit. But we had an instance recently where we very nearly picked one paint product over another paint product based on its EPD, only to find that one was accounting for just one coat of paint and the other one had 2 coats of paint. It is incredibly easy to miss something as simple as that. And they both say, per square meter of paint coverage, actually, you need to read all of it and just really sort of soak it all in. So just be very careful.
Thanks, Joe. Yeah, I mean, that perhaps leads on to another question, Joe, Jack, whilst we have you here. Wendy Young asks a question about tracking a project from through to completion, and is interested to know if you see the carbon slowly increase as you're adding more detail.
Yeah, so we not necessarily, but typically. So one thing in FCBS Carbon is that we tend to exclude things that we'd always have. So it doesn't have any sanitary wear in, for example. Now you can pick better sanitary wear than others, but you're probably always going to have a bog in there somewhere, and you're probably always going to have things like door handles and whatever else. So we do tend to see this tend to pick up as we include more aspects of it. But as we get further on down through it, really we can actually start to be a bit more focused and start selecting products. So you can go down as well. We do actually within FCBS Carbon have a 10% uplift that sits in the background and just bumps everything up to make it a bit more conservative. Typically,
as a sort of contingency sort of fund, if you like.
Exactly that. Where projects where we have a big focus on embodied carbon, we tend to see it go down, to be honest, because we're looking at it and we're measuring it and we're counting it. So even though we start to expand stuff in, it can still go down. So yeah, it's a bit of both, really.
Yeah, and a question for you, Joe Jack, as well as I'll get Tim to answer this afterwards. There's a question about the databases that you're both using. Forgive me if you mentioned this already, but which database is the FCBS tool based on?
So ours is mostly the ICE database. So it's just generic products. And again, this comes into that kind of accuracy thing. So sometimes it will go up if you think it's an industry average. So you might find all of a sudden you're importing plasterboard from China. I don't know whether that's a thing, but you might find also you're using something far more local, which is slightly better, say. So it can go up and down. The ICE database is a pretty good start for all these things. For specific items, I think we've got ComFloor in there, and I think there's a few other bits where we've got a proper EPD, and it becomes so much more accurate as a consequence. So
yeah. And Tim, what about your software? What database are you using?
Well, we did start from using the ICE database as well, and that was about a year ago, and we changed to EPDs because now we've got 200 EPDs in there because we found that we couldn't get this whole life information from the ICE database. We needed to get this C and B in there, and we could only get that from the EPDs, and in fact some of the time they don't even include it. But it's a real help having at least the capability of having all that there, and so we're using that. We've got about 200 that manually entered by me.
Gosh, I mean, just to sort of reaffirm that, that's an amazing amount of work to put into it. So it's kind of amazing. I would point out, seeing Tim's reminded me that I didn't really talk about how we predict modules B and C and A3, A4 and A5. We take a very quick and dirty approach is probably the way to look at it, and we use a percentage uplift to make sure that we kind of have something in there. Whereas Tim and the PHribbon, you can really see, you can make decisions about where your materials come from. So there's far more detail in there.
Brilliant. And I think the last one I wanted to raise, Jane, you've actually already answered this in the chat, but I wonder, could you just cover again the assumptions that are made about timber at the end of a building's life?
Yeah, so basically the carbon that's sucked up by the timber, that's stored in the timber, that's counted in A1 to A3. So that's the benefit that you saw in Tim's graph, the kind of negative under the graph. At the end of life, pretty much whatever happens to that timber, it's considered as an emission. So if it's burnt, either for energy recovery or it's incinerated, then it's obviously emitted. So you get exactly that same amount of carbon released. If you recycle it, so you make it into chipboard or you make it into something else, then effectively it's transferred. So it has to come out of your life cycle and go into the next life cycle so they can show the benefit of carbon storage. So it's treated as an emission. And if you landfill it, there are lots of different assumptions, but effectively you either release it as CO2 or you transfer it to CO2 or methane, or you treat it as a transfer to nature. So you can't permanently store it.
Brilliant, thank you. Tab, I think we're nearing the end of our session. I don't know, did you have anything you wanted to mention to all our delegates tonight?
I do, thank you. First of all, thank you, Adam, for fabulous chairing, and to all our speakers. Let me just share screen. And so to all the students in the room, and in fact, all the participants in the room tonight. So I work for TRADA and the Timber Trade Federation and deliver the University Engagement Programme. If you head to TRADA, come onto the academic page and you will get to your Riverside Sunderland page. Scroll down if you have yet to enter. We're talking here about the webinars. You've got the prizes here, entry requirements, and fill in your, you register here. And then you'll get an email from me pretty much actually every day this week and into next week, and you'll be first to hear about next week's programme. We're also working with Mobi. And so you can head to the Mobi Riverside site and same information. Come scroll down, all the same, information. And there's a couple of videos on the bottom of here, a nice flyby. And then you head to our major sponsors page. So this is the Confederation of Timber Industries. And this is why we're able to put this on. And they're going to be paying your prize money should you choose to enter, and should you choose to choose to win. If you win, if you're
lucky enough to win,
yeah, if you come up with a fabulous design. So on the CTI, scroll down it, you've got the webinars, you've got the week 1 program, and then we've got a synopsis here every day, and a shout out to Jessie for that. Let me hopefully now turn that down. And are you seeing what I'm seeing? You're seeing our fabulous speakers tonight.
It's like a rogues gallery.
Ah, fantastic. Huge thank you to you all. And I mentioned CTI, but Arcoya are our gold sponsors, Rosoplas also, along with the Timber Decking and Cladding Association, PEFC, who spoke last night, and our bronze sponsors, the Alliance for Sustainable Building Products, I think are in the room tonight, Wood for Good, who was mentioned in the chat, the EPDs, and BSW Timber, who are also here tonight. So tomorrow we have a virtual pub. So if any of you would like to attend, the links where you signed up, at Eventbrite, come along. We start at 6. It's very informal. I said, grab a drink, could be a coffee, could be something stronger, get out of work mode and come and have a chat. And some of our speakers here tonight, I know, are joining us, so you'll have a chance to come and ask them more questions. So this is the end of our webinar program for this week. Let me stop sharing. But next week, in the Riverside Sunderland Online University Design Challenge, we're going into teams and why it's so important to work as teams. And we'll be looking at desirable homes and communities. On Tuesday, we will have Goldsmith Street and Positive Homes. So Goldsmith Street, Sterling Prize winners, they're going to bring 4 team members to come and talk to us. Positive Homes, again, will bring 4 team members, and that's on Tuesday. On the Wednesday, we have the Homes of 2030 shortlist, 2 runners-up, the Positive Plus House and Forever Homes. And then on Thursday, we're going to have as-built homes. So we have Larch Corner, which is a CLT frame. We have Ackerman Road, which is a Passivhaus 15 frame. And we have, I'm going to say this wrong, Gymnasium, which is a timber frame. So it's a homegrown timber frame with natural sips. So that's next week. So hopefully I will see you then. And thank you for participating. I'm just stopping the recording. Do you want to stop cloud recording?